Have you ever pondered about where it all started, the origin of the universe? A question that has intrigued philosophers, scientists, and thinkers throughout the ages. The birth of the universe is not just a historical event, but a key to understanding our existence. It's about piecing together the cosmic puzzle, about appreciating the marvels of space and time. It's about us, and our place in this grand cosmic theater. So travel with us on this cosmic journey from the very beginning to the present day. Our journey begins around 13.8 billion years ago, with a monumental event known as the Big Bang. Imagine the universe as we know it, shrunk down to an infinitesimal point, a point so small it's impossible to perceive. Yet, within this point, the entirety of what we now call the universe existed. This was the singularity, a state of infinite density and temperature where the conventional laws of physics were twisted and bent beyond recognition. Then, in a fraction of a second, this singularity began to expand. Not a simple explosion, but a rapid stretching of space itself. This is the Big Bang. It's not an event that occurred at a specific place in the universe, but rather, it was the birth of space and time itself. In the first few moments of the Big Bang, the universe was a hot, dense soup of particles and radiation, far too hot and dense for atoms to form. As the universe expanded, it cooled, and after about 3 minutes, it was cool enough for the first atoms to form. These were primarily hydrogen and helium, the simplest and lightest elements. But how did we get from this soup of particles to the universe we see today, full of galaxies, stars, and planets? Well, that's where the physics comes in. Quantum fluctuations in the early universe led to tiny variations in density. As the universe expanded and cooled, these variations grew, eventually leading to the formation of the first structures in the universe. Through the process of gravitational collapse, these structures grew, eventually forming the first stars and galaxies. Thus, from the hot, dense, uniform state of the early universe, complexity arose, leading to the diverse and fascinating universe we see today. Thus, from this singularity, the universe as we know it was born. Fast forward several 100,000 years, and the universe begins to cool and expand, leading to the formation of galaxies and stars. Imagine the universe as a vast, ever-expanding soup. As it cooled, the soup of the universe became less dense, allowing for the formation of protons, neutrons, and electrons, the building blocks of matter. These particles began to combine, forming hydrogen and helium, the most abundant elements in the universe. As the universe continued to cool and expand, these atoms began to gather under the influence of gravity, leading to the formation of the first stars. But how exactly does gravity come into play? Well, gravity is an attractive force that pulls matter together. It's like an invisible thread that connects everything in the universe. When the universe was young, it was filled with these hydrogen and helium atoms randomly moving around. But gravity, being the irresistible force that it is, pulled these atoms together, creating denser regions in the universe. Now here's where things get interesting. As these regions became denser, they exerted a stronger gravitational pull, attracting even more atoms. This process continued, leading to the formation of massive clouds of gas and dust, known as nebulae. Within these nebulae, the atoms were so densely packed that they began to collide, sparking nuclear reactions and giving birth to the first stars. These stars didn't exist in isolation. They were part of vast galaxies, collections of billions of stars bound together by gravity. The process of galaxy formation is a complex one, governed by the interplay of gravity, gas dynamics, and stellar evolution. But in essence, it's the same story. Gravity pulling matter together to form larger and larger structures. And so, the universe began to light up, one star at a time, forming a cosmic web of galaxies. Each galaxy, a unique masterpiece, a testament to the power of gravity and the cooling, expanding universe. As time went on, these galaxies and stars would serve as the building blocks for the universe. Around 4.6 billion years ago, in a relatively quiet corner of the Milky Way galaxy, our solar system began to form. This was a time of immense change and creation. In the great cosmic dance of the universe, a cloud of gas and dust began to collapse under its own gravity. As this cloud contracted, it started to spin, flattening into a spinning disk with a hot, dense central region. This central region would eventually become our sun, the heart of our solar system. The surrounding disk, rich with a mix of elements, wasn't idle either. It was in this disk that the seeds of planets, asteroids, and comets were sown. Tiny particles of dust began to collide and stick together, in a process known as accretion. Over time, these small clumps grew larger and larger, forming planetesimals, the building blocks of planets. In the inner solar system, closer to the sun, it was too hot for volatile compounds like water, ammonia, and methane to condense. Thus, the terrestrial planets, Mercury, Venus, Earth, and Mars, were formed, primarily from rock and metal. Further out in the cooler regions of the solar system, these volatile compounds could condense, leading to the formation of the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. These planets are much larger, made up of layers of gas and ice surrounding a solid core. But what makes our solar system truly unique is our home, the Earth. The perfect distance from the sun for liquid water to exist, a magnetic field to protect from solar radiation, and a stable orbit for consistent seasons. These are just a few of the unique conditions that made life on Earth possible. From a cloud of cosmic dust and gas to a system with a life-giving planet, our solar system's birth is a testament to the beauty and complexity of the universe. And so, our tiny corner of the universe was born. From the birth of our solar system to the present day, the universe has been constantly evolving. Every second, every minute, every hour, every day, every year, the cosmos is a buzzing hive of activity, a symphony of creation and destruction playing out on an unimaginably vast stage. Let's consider the formation of new galaxies. Imagine a cloud of gas and dust floating idly in the vast expanse of space. Gravity, that unrelenting cosmic sculptor, pulls this material together, condensing it into a swirling mass. Over time, this mass spins faster and faster, flattening out into a disk shape. The center of the disk grows dense and hot, giving birth to a new galaxy, a new home for future stars. Stars too have their life cycle. They are born from the same cosmic dust and gas that form galaxies. A star's life is a battle against gravity. It burns brightly, fusing hydrogen into helium in its core, pushing back against the inexorable pull of gravity. But eventually the star exhausts its fuel. What happens next depends on the star's mass. A small star fades away quietly, while a large one explodes in a supernova, a brilliant flash that outshines an entire galaxy, seeding the universe with the elements necessary for life. But the universe isn't just about creation, it's also about expansion. Since the Big Bang, the universe has been growing, stretching out in all directions. This expansion is not slowing down. On the contrary, it's accelerating, driven by a mysterious force we call dark energy. This means that the universe's future will be vastly different from its past. The universe as we know it is a dynamic, ever-changing entity, constantly evolving and reshaping itself. Every moment, new galaxies are born, stars live and die, and the universe expands further into the unknown. The story of the universe is a tale of constant change, a testament to the power and beauty of nature's creativity. Today, the universe continues its ceaseless journey of evolution and expansion. It's an unimaginable cosmic ballet, where galaxies whirl, stars are born and die, and new worlds are continually crafted. Currently, our universe is approximately 13.8 billion years old and still growing. Our place, the Milky Way, is but one of 2 trillion galaxies, each teeming with a myriad of stars and celestial bodies. Scientists predict a future where this expansion accelerates, leading to a universe that grows colder and darker. But this is billions of years away. Today, we are in the stelliferous era, a time of starlight and cosmic vitality. Yet, the universe keeps its secrets well. From the enigma of dark matter to the puzzling acceleration of cosmic expansion, mysteries abound. We're still grappling with questions about the nature of black holes, the possibility of parallel universes, and the elusive search for extraterrestrial life. The importance of our continued exploration cannot be overstated. Every new discovery, every breakthrough peels back another layer of the cosmic onion. Each question answered gives birth to a dozen more, pushing the boundaries of our understanding further into the unknown. As we continue to unravel the mysteries of the universe, we realize that our journey is far from over. The universe in all its grandeur and complexity continues to inspire and humble us.